Hello everyone, we are the fourth group. Today we are going to introduce the Poulton turbine. The principle of Poulton turbine is after high pressure water flows through the needle valve, spare water onto the leaves. Use the blades to drive the rear wheel. Let it use the kinetic energy of the water flow converted into mechanical energy. Next, we have to introduce the equipment. Let's introduce it in order from here. This is an impeller. When the water flow pushes the impeller, it converts the kinetic energy of water into mechanical energy. This is needle valve. Its function is to adjust the water flow. The size of the water flow entering the impeller. Here are 6 breathing weights. Next is introduce the water pipe pressure gauge above. There is a flow meter for the water pipe here on the right, used to observe the flow entering the water pipe. Next is the core of the equipment, the pump. Its function is to remove the water from the water tank into the water pipe. This is a tachometer. Can let us know output speed. Finally, introduce the switch. The right one is on and the left one is off. Next, we will introduce Poulton turbine experimental process. Step 1. Check the needle valve opening. First, turn the needle valve to position 1. The pressure in water pipe should not exceed 5 bar. To prevent excessive water pipe pressure. Step 2. Check if there is still water in the water tank. If there is no water, remove the black round lid. Turn open. Added water. After checking if there is enough water, make sure your hands are dry. Step 3. Connect the power supply of the device. Step 4. Turn on the power button on. Press the black button to start the turbine. Then, according to the different experimental parameters, adjust needle valve opening. Record the pressure, flow rate, and the flow meter. Next, record the speed under no load condition and the rotation speed under different weight control rates. After all our experimental data are recorded, just turn off the power. Press the off button. Turn on the weight to its place. Unplug the power cord. The above are the operating steps of the Poulton turbine.
The purpose of this experiment is to measure the efficiency of Poulton turbine. Start with the efficiency equation. The efficiency equation is output work divided by input work. The work input is given by the specific gravity of water multiplied by the flow rate and multiplied by the total energy. Water-specific gravity is a fixed value. The flow rate is measured by a flow meter. The total energy is substituted into the energy equation. The energy equation is pressure energy plus potential energy adding kinetic energy. We get part of pressure energy is determined by the pressure gauge divided by the radius of the water pipe. The potential energy part is measured by the height of the water pipe. Kinetic energy is caused by flow rate divided by 2 gravity acceleration. Flow rate required by kinetic energy formula equal to what is measured by the flow meter. Flow rate divided by the pipe, tube area, by the value we just calculated. Bringing back the formula, we can get the input work. The output work is given by torque times angular velocity. The torque part is given by the weight of the weight times the relative moment arm. The angular velocity is multiplied by 2 pi with the tachometer. The measured speed is divided by 60. By pushing back, the output work can be obtained. Finally, divide the output work by the input work. Will get us eventually efficiency data to be obtained from the experiment. Next, we need to analyze the experimental data. Analyze and discuss theories. The relationship between flow rate, nozzle cross-sectional area, and inlet pressure. Generally speaking, the larger the cross-sectional area of the nozzle, the higher the inlet pressure. The traffic will also increase. This is because the traffic Q cross-sectional area A of the nozzle and pressure difference delta P have a close relationship, where ρ is the density of the fluid. It can be seen that under the same pressure difference, the flow rate is proportional to the cross-sectional area, and under the same cross-sectional area, flow and inlet pressure proportional to the square root. The relationship between speed and flow, while keeping the cross-sectional area constant. The greater the flow rate, the greater the flow rate. When the flow rate Q increases, the flow velocity versus will also increase accordingly. Effect of weight of weight, impact on the system, may involve system balance, resistance, or other factors. Effect of needle valve position. Needle valve position changes on flow and speed. There is a significant impact. Adjust needle valve can change the system, pressure and flow rate. It can be seen from the data analysis that, like the relationship between efficiency and speed, efficiency usually increases with increasing speed. Efficiency, speed, input power. The relationship between the output power and the relationship between nozzle speed and runner speed. But this is related to factors such as system design, materials, and load. Relationship between input power and output power. During the energy conversion process, the greater the input power, the output power will also increase accordingly. However, this does not indicate efficiency. It will have 100% output efficiency. Losses during energy conversion, such as loss, friction, etc., will lead to reduced efficiency. Relationship between nozzle speed and wheel speed. Nozzle speed and wheel speed. The ratio between the evaluation system. An important indicator of energy conversion efficiency. Generally speaking, the larger this ratio is, the indicates systematic. The higher the energy conversion efficiency. Effect of torque. The role of torque in system operation, involving driving forces and stability.